So my name is Matthew McPherrin. I work at Let's Encrypt as the tech lead of the SRE team, who both runs our CT logs as well as runs the CA which submits to the CT logs. So I probably don't need to introduce Let's Encrypt too much in this audience, but we're a free, automated, and open certificate authority brought to you by the nonprofit Internet Security Research Group. Our goal is to encrypt the web. We offer free certificates via the Open Acme protocol, which allows many different software products to build certificate issuance into it, allowing easy and automated certs everywhere. And I think we're succeeding at that goal. We issue millions of certificates every day and are continuing to grow with a curve that is slightly worrying to me as I plan our capacity. But I'm not here to talk about the CA today, while Let's Encrypt is a major CT client submitting lots and lots of certificates. We are also a log operator, as Joe mentioned, and that's what I'm here to talk about today. Because, we've talked a lot about running a log in very vague terms, but, apparently this is the meme image of the day. We'll talk a little bit about drawing the rest of the owl. So we have one trusted log right now, which is named Oak. It launched in 2019, running Trillion, which is the most popular CT log implementation today. Or at least many of the log operators are running it. We run it in a Kubernetes cluster with storage in MariaDB on AWS. There's about 4.5 billion certificates in it. The patch to Chrome marking it as qualified was 5 years ago on Tuesday, so that's very exciting. I think there's probably some familiar names in this CL. But it's not just one, 4.5 billion certificate log. So we have temporal sharding based on initially years, but starting this year in 2024, we started to get concerned about the size of individual shards. So we're now going to half-year shards. So the current 6 shards we have active, which is 2024 through 2026, are half-year. And the biggest of those shards currently has about 1.2 billion entries in it. The architecture diagram here is a little complicated. We currently have about 100 pods running on a Kubernetes cluster on this sort of big microservice-y thing. It's possible to fit the whole architecture on a slide, which is, not a lot of systems can do that necessarily, but there is sort of a lot of resources going on here. Roughly, it is 7 Kubernetes workers, which are these C7A 2x large Amazon VMs, which is like 8 CPUs, 16 gigs of RAM. The big databases, which we have per shard right now. I mentioned, temporal sharding. Actually, initially we ran multi-tenant the first couple shards in a single MariaDB, but then we started hitting into size limits on what we could fit in 1 DB. So then we started running multiple DBs, and then we hit those size limits again, and now we're running these half-year shards, which are even smaller. And then probably the biggest resource for us is the bandwidth. We're doing about 10 terabytes a day. It's very spiky, but that sort of works out to be about a gigabit per second continuous read traffic out of it. And that's where a lot of these pieces of infrastructure need. We do have one non-standard component that is not part of Trillion, which, because of the read traffic we had, we just really couldn't sustain it coming straight out of the MariaDB instances. So we used to actually have much larger, much more expensive DB instances than we do today. And we were still having scale trouble. I think Joe sent us some angry emails about our log uptime. We could have probably started rate limiting harder, but we didn't really want to do that because the whole point of CT is to get that data out to everyone. So we wanted to, focus on that read scalability. So we wrote our own S3-backed read cache in front of Trillion, which serves the bulk of our read traffic today and has sort of better horizontal scalability than our previous reads coming straight out of Trillion. So I did mention, we've had some scalability problems. A lot of that has been related to DB overload. We've had other issues. We had one test log that actually died. Our test log was called test flume, which contained sort of the sole Let's Encrypt production traffic as well as our staging. So it was just a bit bigger because of that extra staging. So it hit a 16 terabyte size limit in MariaDB on RDS table size limit, which was fortunate that we hit it in test flume, because if this had happened in production, it would have killed the several oak shards because they were still on the same database at the time. So we sort of hurriedly tore down test flume and split oak into multiple databases so that we didn't have the same problem again. Our current half-year shards are approaching 8 terabytes. So if we had them still in single-year shards, we would be at risk of running into this limit again, which is one of those things that concerns us because we don't want to hit limits that knock our log over. In the sort of near miss category, we've had a couple times where we have either had no signer running because we were migrating to a new Kubernetes cluster and had to migrate the workloads over and something went wrong. So we had a period of time with nothing signing, which leads to an increasing merge delay, which we'll talk a little bit about later. And we've also accidentally run multiple signers at the same time, which you're not supposed to do. Again, usually because of stuff like migrating to a new Kubernetes cluster and the etcds aren't wired up properly for their leader election. But we haven't killed a log yet, so I'm cautiously optimistic we will continue to not do that. There are a couple interesting ways that logs can die, and this is sort of the things that we're worried about frequently. The maximum merge delay is sort of the thing that is our continual haunting ghost that we have to worry about, because if something sort of goes wrong, we accept some logs, we accept some certificates into our log, and we don't merge them, then we sort of have this commitment to have them in there in 24 hours, which means that we have to have a 24/7 on-call and respond at all time of the day. Other than missing the MMD, there's other things that can go wrong. Corruption of the log data itself. I think Yeti 2022 had a bit flip. There's other sorts of corruption that have happened. Mammoth 2024 H1 had a disk fill, which caused some database corruption and led to some unmerged certificates, which isn't great. There's sort of generic security problems. DigiCert's log 2 had their configuration management system compromised, which potentially exposed the private key for the log itself, which is sort of a concerning thing that is something that we're worried about the complexity of the log, because the more components you add, the more things you have to secure. So that's something that we want to really focus on simplicity for security's sake. And then downtime. The whole point of CT is to make the data available. I think one example from 2023 was Nimbus's log from Cloudflare went down when they had a power-related data center thing that brought them down for a couple days. I think they did end up missing some MMDs, but we decided as a community to allow them to live. But Let's Encrypt does not want to be in a place where we have to, pray that our logs are allowed to live to Caesar. And so, we're worried a lot about these things, which means we have a lot of alerting on our logs, which has a flip side of we have a lot of alerting on our logs. And as a team, I was getting woken up by a pager way too much. It's sort of in 2022 and 2023 was probably one of the biggest pain points in our on-call rotation as a team. And so we really started to think, how can we do better? I already mentioned CTILE, the read proxy. That was the first thing we did immediately to reduce that read load to make sure our scale could support the read load we were getting. But we still had a bunch of other things we were worried about, including the merge delay and just the generic complexity and the difficulty of operations of, having to run these Kubernetes clusters and etcd clusters and the various components. So we decided that we wanted a new simple CT log operation targeted just for CT, for our use case that sort of met our needs precisely. We had been running this CT log for 5 years, and we had formed capital O opinions about what we wanted. So on our wish list, number one, we want it to be simple to run. We want more CT log operators to exist, so we want it to be easy for us, but we want it to be easy for others. And that means we want a cost-efficient, simple to operate, low barrier to entry log. And if we're going to go through all of the effort to make a new log, it really needs to be dramatically simpler, dramatically more cost-efficient. So we're not just looking at Trillion, which is great software, but we're also looking at all the bits that we run around Trillion, like the etcd for leader election and our RDS databases on Amazon. It's the full ecosystem of components. Kubernetes, I don't want anymore, if I can. We want to get rid of merge delay. So it's one of our biggest fears with CT because we accept add chain requests and then fail to merge them. We're in a bad situation. We just don't want to have it. This has been discussed, over the years multiple times by different parties, that we think a CT log should be able to sequence and sign fast enough that we can avoid returning SCTs until after the entries are already in the log. And that really helps us with the simplicity goal, because me, as a groggy engineer woken up at 2 a.m. because my log is returning 500s, I can be assured that I'm actually not worried about missing merge delay or worrying about unsequenced data because it doesn't exist. I can just fix whatever is causing those 500s and not worry about any additional remediation items that I might need to do to resequence things that have been lost or something. I think a great example of this is one log that had its disk fill up earlier this year, had accepted some SCTs, and the table got corrupted and those entries were lost. That's sort of failing the goals of CT of putting it in the log and trusting that it's there. So with no merge delay and the throughput of CT, which is sort of 100 certs a second or something, we think we can handle this with a single process. And that means it's a simple, no microservice, no RPCs, no failure points, one piece of code that runs. We can monitor, we can see how its CPU usage and memory usage is, we can look at its log files, and we don't have to worry about failing leader elections or worrying about the complexity around it. And with a zero merge delay system, there's no coordination needed for sequencing, so it sort of pushes together into a more simple system. The next on our big list of wish list is we specifically wanted to use object storage to store our data. Up until now, Oak and the predecessor logs we tried to run before Oak, which I didn't talk about, but this is not the first way we tried to set it up, and the first couple didn't work nearly as well. We tried some sort of MariaDB horizontal scale, some sort of system, and it hasn't quite been a great alignment. CT logs are append only, they're immutable. And a relationship is not really, a relational database is not tuned for that. It supports fancy queries, updating rows, doing big join operations. That's not really what we're doing in a CT log. So, the cost of running these big databases isn't well tuned for what we want out of a CT log. We already had great experience with the CTAL cache running an object storage backed read proxy, and so we wanted to push the actual log to storing its data in that object storage. For us, that means AWS S3 because we're hosted on AWS, but I think at this point object storage is a bit of a generic commodity. Our hosts here at Google have a version called Google Cloud Object Storage. That might not be right. But there's also open source projects like Minio and Ceph, and commercial offerings from data center storage vendors. If you are doing it yourself in a data center or something, scaling out Minio on a bunch of Dell servers you buy is a lot easier than scaling out a big horizontal MySQL cluster too. So even if you're not in a cloud environment, it's still a great option from an operations point of view. So we had this design in mind of a single writer backed by S3 and maybe some horizontal scaled readers serving the classic CT read APIs. But we started, chatting this design around, in particular to Filippo, and we realized that we could actually be more ambitious with this. Other transparency systems, such as Go's checksum database, had a newer design based on tiles. You've certainly heard about the static CTP API so far today. So we started really thinking like, well, actually, yeah, our storage format in this object bucket doesn't have to be served via some modified version of ctile. We can actually expose that directly. And as an operator, that's really exciting because a CDN backed by an object store is commodity technology. It's cheap. I can scale it out. I can switch vendors. I have lots of tools to deal with the data, whether that's rclone to sync to another bucket, cloud native operations to copy and back up data, or just like rsyncing it to a file system and putting an Apache in front of it. The actual tile format is pretty interesting. Trillion uses a tile format internally, and you've heard about this a lot, but you have these nice, easy to reason about files that you can work with through any of your normal file mechanisms. My lovely diagram here shows tiles of width 4, but in the actual CT static API, they're 256 wide. The yellow nodes that are sort of in part of these interior trees are omitted for storage compactness because it's a Merkle tree. You can sort of hash up the tree. And then the final layer at the bottom, the data tiles, are just the certificates in their own files. And then you get nice, clean HTTP paths that map into these. So that top tile is sort of level 2, tile 0. And then that its first child to the right is level 1, tile 1. And then tile level 0 is the one directly above the data, and then your data at the bottom. So this is like a really clean, easy to work with format. And like I've already written a bunch of tools that can work with this in a way that's sort of nicer than having this fancy REST API for the different things. There is one thing, though, which is that this sort of offloads some of the complexity of inclusion proving to the clients who have to know what tiles to load, construct them, and then do these things. And there is one bit that's sort of hard to do with tiles, which is the RFC 6962 endpoint get proof by hash, which given a certificate's hash returns the inclusion proof. As someone on the internet, if you have a certificate, you want to verify its inclusion of a tree, you can just take the hash of that cert, call this API, and get an inclusion proof. With just a set of tiles, there isn't really an option to do that. So as an alternative for the static CT API, there's an SCT extension which contains the index in the log of where that certificate will be sequenced. So you can take that index, calculate what tiles you need to load those tiles, which is, again, a nice, cheap, and efficient operation from a CDN and caching endpoint, in contrast to get proof by hash, which I can't cache across lots of different certs, because every single cert is going to have a different get proof by hash return value, so there's no cacheability there. So you take this index, you load your tiles, and you get an inclusion proof. This also makes detection of misoperating logs a lot easier, because I know where, as soon as I have an SCT, it is supposed to be in a log. You don't have to wait 24 hours for the maximum merge delay to decide that a log is operating. As soon as the log head moves past that index and you see there's a different cert in that thing, that means the view has split. Or if a log is sitting stuck at an old checkpoint and hasn't progressed far enough, you can immediately see that SCT is missing. So this both makes it easier for us as an operator, for log monitors detecting it, but it does make it a little harder for some people who just want to verify a cert is included in a tree. They need a bit more code. This is using the extension field on SCTs. That field has always been there, but we haven't used it up until this point. So that's a potential point of incompatibility that I don't think is going to be a problem, but as we get into the nitty-gritty, is something to consider. So we have this design. We want a single writer for simplicity of operations, tiles stored in object storage behind a CDN with no merge delay. So that brings us to Sunlight, which is the implementation that we are currently running. So we partnered with Filippo here in the audience to lead the design and implementation with feedback from other members of the certificate transparency community, including Trust Fabric and Chrome here in the room, SigSum and others who we want to build this thing that starts to look more like other logs, so it was important to collaborate with a lot of different people. It exposes the normal CT add chain and add pre-chain endpoints, so CAs can submit today, same as they always do, and monitors can start consuming the static CT API. In contrast to the last architecture diagram I had, Sunlight is dramatically simpler. Instead of 100 pods and 7 VMs, I have one single process on one single VM. Reads go straight from my CDN to the S3 bucket. Writes go to Sunlight. Sunlight has two dependencies, one of which is the deduplication cache, which is stored on a local network file system, which is just a SQLite, which ensures that if you add the same cert to a log twice, we can just return the previous index. That is actually non-critical. If the file system fills up, which one of our test logs had happen, then it just will accept it into the log again, or otherwise, not fail, which is a big contrast to the Mammoth 2024 H1, where a full file system killed the log. This actually ran with a full file system for like a whole week before I even noticed, which also meant I needed to fix my Prometheus alerts, but that's a different issue. As well, there's the lock backend, which runs in DynamoDB, which just prevents accidentally running 2 copies of Sunlight for the same log. It's a safety mechanism. I mean, I'm not going to run multiple writers, but if I did, the DynamoDB prevents that. Unlike the etcd cluster, I don't have to run it either, which is important to me because we have messed up our etcd cluster more than once. The compute resources are relatively tiny. I'm running on a single AWS T4G small, which is 2 vCPUs at 20% burstable capacity and 2 gigs of RAM with 100 gigs of EBS local storage. And then the object storage, approximately the same as what we had for CTAL already, so it's not an increase. And then the CDN bandwidth, which also should be smaller because the tile representations are both compressed and less verbose than the classic CT get entries API, so we expect significant bandwidth savings on that side. Though actually, on bandwidth savings, this log is a lot harder to knock over. So it could be that the misbehaving scrapers, which currently cause us to fail and crash, instead now successfully just use up a bunch of our bandwidth. I think that's a trade-off we're okay with. It might make the bill go up, but the logs keep running. I think that's probably good for the ecosystem overall, but we'll have to see how that goes. We're currently running 3 instances of Sunlight. They currently have 2025 shards provisioned, and we'll have 2026 ones in the near future. Twig is our test instance that our staging environment submits to. And if you're another CA who has your own test instances, you're welcome to submit to Twig as well. Sycamore and Willow will become trusted logs once the CT log programs are willing to accept Sunlight logs. And Let's Encrypt production environment is currently submitting all of our pre-certificates and all of our final certificates to all 3 of these logs. So that's sort of a full Web PKI worth of traffic that we're observing on these, just because I would say Let's Encrypt is about sort of half the number of certificates issued to logs. So normally, we submit to one of our own and one of another, or 2 other operators. So all of our logs having all of our certificates is sort of a multiplicative traffic effect. So we're pretty confident at this point that this is basically working. These are still a little bit of a test log. I think some of our CDN caching settings and things might not be quite right, but we're really interested in getting these going. So, of course, this design has some trade-offs, and I want to explicitly address them. The first thing is that we have this single writer with no leader election as just a VM. So as Joe mentioned earlier, the CT log policy SLO is 99% uptime, which is not that high of an uptime. And we think that even without a leader election, if a VM fails and we have to wait 10 minutes for Amazon to reschedule it to a new instance, that we're well within that, plus the regular maintenance. We're actually just if we deploy a new instance, we just tear the VM down and replace it. So it does go down for a couple minutes during that time. So, that's an interesting approach. I think we'll have to see how that goes and how the ecosystem tolerates it. But we're, certainly interested in trying. Again, because of simplicity, it's a lot easier to run the log that way. I talked about the no merge delay. We're really afraid of it. It is a source of headaches and concern and potential ways to kill a log. So we want to get rid of it. But the thing is the merge delay serves a purpose. So with no merge delay, there's an obvious corollary, which is that you have to wait for the merge. So on Oak, in Trillion, the 75th percentile latency is 100 milliseconds as it just writes a row unsequenced to a database. With Sycamore, that 75th percentile latency is 1 second. And this is measured from Let's Encrypt to 2 logs running in the same AWS region. So there's sort of, similar, from the CA perspective, latency and everything. From our perspective as a CA submitting to a log, we think 1 second is acceptable. We use the ACME protocol. The finalize operation, which is when you submit a CSR and you get back a cert and is where the CT log operation happens, is at least in theory asynchronous, though we've had some bad client software, so we actually haven't enabled asynchronous finalization to avoid breaking Plesk. But we are okay with this within our own margins of things. This is something I really want to hear from other CAs about, is 1 second to submit to CT okay? If you're issuing 10 EV certs a day by hand with an operator clicking a button, then I would suspect it is. If you're Let's Encrypt and we're fully automating, we think it's okay for us. What about someone in the middle, maybe running off-the-shelf software or running medium volumes? I'd love to hear discussions from people about this. We could potentially mitigate and lower this if that's required, but that's something I'd love to hear from other CAs about before we start trying to tackle that time down. Of course, the biggest thing is the static CT API requires the log monitors to update. It's a new API. It's a big lift. It's something that, we're concerned about. Some log monitors like Census have already started monitoring our new logs, but there's a long list of them. I think based on our traffic, we estimate about 10,000 people monitor our logs in terms of monitors that pull the full tree out. So, I know of 3 of them right now that support it. So that's, another 10K minus 3 log operators to go, or monitor operators to go. The other thing about the static CT API is this SCT extension. We're always worried about adding data to a field that hasn't been used before because maybe, I've certainly Google searched how do I parse an SCT and found some janky Python on GitHub. And I don't know how many people are running those janky GitHub scripts that are, not really maintained. If you are, you should use the PyCA cryptography project, which is a nice, robust SCT parser. So there's a bunch of trade-offs that we're making with design. Are they worthwhile? We think so. There's one really, really big reason why we think it's worthwhile, and that we can run more smaller, cheaper logs. So I talked about Oak with 7 compute nodes plus 6 database clusters. With that same infrastructure as a log operator, I can run more logs. And that means a more robust ecosystem. CAs already have to choose between multiple logs to submit to. So effectively, we already have this distributed system that is handling log downtime. And a single, disqualified log from a batch deploy or a meteor strike or a full hard drive isn't nearly as impactful to the ecosystem if we have multiple logs. We can spread these across multiple cloud regions and availability zones that just increases the system's overall reliability. And in fact, on Tuesday, we saw this. AWS S3 was unavailable for 22 minutes in US East 2, where we currently run both Oak and Sycamore. Sycamore just went down. It was unable to sequence because it couldn't write SCTs, so no SCTs got returned to CAs. Twig and Willow, running in different regions, were up. It's fine. As a CA, we can still submit. But on the other hand, Oak's read path was significantly degraded for those 22 minutes. Because we can't handle that read from our database alone, monitors were unable or very delayed in getting data out of Oak. So that means that, while we were returning SCTs to CAs and we were well within our maximum merge delay, the goal of CT, of making those certificates available widely, was not successfully being met. And so in this case, we think that even though in theory those single writer logs might have lower uptime, having more logs in multiple regions with different disaster recovery properties makes the whole system more robust. And finally, I'm really hopeful for a CT ecosystem that has multiple high-quality log implementations which make different trade-offs. We don't think that everyone should run Sunlight. In fact, maybe we'll be the only CA that runs Sunlight, or a new log arbiter will additionally run it. But other people might want to run Tessera. They might want to continue running Trillion. They might want to run some new CT log option that is backed by, serverless compute and a key value store. We've got a lot of variety of how these things can be implemented, and I think that'll also further increase the robustness, reliability from that sort of SRE perspective of software variety, different options, and overall robustness. So where do we go from here? The big thing is that we're running the logs, but that's only really the start. So we need to get log monitors to support the static CT API and to consume those. We need to get browsers trusting the Sunlight logs so that we can start including those SCTs and certificates. Chrome has sort of suggested that's coming soon, and Apple has also said that they intend to support them in the future. And Let's Encrypt is going to begin pulling SCTs from these logs in production as soon as we can. We already are in our staging environment, so if you're concerned about any of the SCT extensions or otherwise testing this code, we invite you to use our staging environment today. As one final bonus thing, Andrew Iyer has released a project called Sunglasses, which provides a proxy that you can get the traditional RFC 6962 CT API backed by a Sunlight log. So if you are a log operator, a log monitor, and you want to start consuming our Sunlight logs today with no additional code, you can just run yourself an instance of this. I'll leave you with a couple resources. Sunlight.dev is the homepage for the Sunlight implementation. c2sp.org/static CT API has the static CT API specification. And the Sunlight channel on the Transparency Dev Slack is where you can find me, Filippo, and others to answer questions about Sunlight. Finally, I'd like to thank the organizations and individual sponsors who help us make our global impact via Let's Encrypt, Sunlight, DivvyUp, and Proximo. Let's Encrypt is a project of the Internet Security Research Group. You can find out about us and all our other projects at abetterinternet.org. And if you're interested in sponsoring our work, you can reach out to sponsor@abetterinternet.org. That's all I've got. So I guess we can, if we have time, do some questions.